So today we're going to look at prime versus composite numbers. Now hopefully these are some words that you have used and seen before, but I wanted to take just one lesson and let's look over and review that just to make sure that we're all on the same page, because the next lesson we're going to start looking at prime factorization. So we've got to really know what prime numbers are because we're going to be using them. So we're going to take just a moment to stop and say, alright, what are those prime numbers? And then you got to know how to compare those to composite numbers. So there's some definitions that you need to know. I definitely want you to write these down. So a prime number is a number that only has two factors, one and itself. Now, this word factors here we'll look at in just a second, but a number that has only two factors, one in itself. So for example, some prime numbers are 2, 3, 5, 7, and there's a lot more of those as well. They go on forever, infinity. But if you think about it, a factor of 2, well, what are some numbers that multiply together to get 2? Well, 1 times 2, that's it. 1 times 3, that's the only thing. 1 times 5, 1 times 7, that's it. You notice it only has two factors, 1 and itself. Nothing else will multiply together to give you 3. No other whole number. Alright? So let's look at composite number. Obviously it's going to be the complete opposite. It's any whole number with more than two factors, which means it will have 3 or more. So for example, 18. Well, what could you multiply together to give you 18? I can think of 1 times 18. There's two factors. But I could also think of 3 times 6 or 9 times 2. So all of those would be factors of 18, making it have more than two factors and making it composite. Now, I use that word factor. I just want to make sure that we're okay with that, because I want you to be able to use these terms as well. And there's two ways to look at a factor. So we're going to start up here with this multiplication example. It says 3 times 4 equals 12. Well, 3 can multiply together to give you 12, so it's a factor. And 4 can multiply times 3 to get 12, so it's also a factor. But you can reverse it and think of it as division, because you could say, like, 12 divided by 6 is 2. So 6 is a factor of 12 because it will divide it evenly. So I could also look at and do the same thing with the 3 and the 4, and I could say 12 divided by 3 is 4, and 12 divided by 4 equals 3. Apologize for my handwriting there. But you'll notice that both of these numbers will divide 12 evenly, giving us an answer with no decimals and no remainders. So they are factors of 12, just like they were up here as well. So you need to get this definition down. A number that multiplies to get a product, such as here, or a number that divides another number evenly. So when we're saying factors, a composite number has more than two numbers that you could multiply together to get that number. So here are some examples of the prime and composite numbers. Now I don't expect you to remember all of these, but I do want you to be familiar with some of them. Now, 1 and 0 are neither. We'll talk about that again in a second. But prime numbers, all of these highlighted in green, the only thing you can do to get that number, 1 times 2, 1 times 3, 1 times 5, 1 times 7, all of those only have two factors. Now, some people like to, they'll say, well, odd numbers, only the odd numbers are prime, and even numbers are composite. Well, that's not true either. You can't say that, because there are odd numbers that are composite. There's 57 I'm looking at right there. It's an odd number, but it's composite. There are more than two factors to get to 57. 77, there's an odd number that, 1 times 77, but also 11 times 7. So that has four factors. So it's composite, not prime. But you look at these, there's 2, 3, 5, 7, 11, 13. Now I will tell you, these first few right here, 2, 3, 5, 7, 11, 13, 17, while I'm not asking you to remember or memorize all the prime numbers, those are important. Those are extremely, extremely important because those will probably be the ones that we see the most when we're dealing with prime factorization. So I really want you to look at those. 2, 3, 5, 7, 11, 13, and 17. Now, all those others are still prime that you see in green, and we might use those, but these will be the ones that you will see the most. So, reviewing again, prime, 1 and itself. Factors of 1 and itself. Composite, 3 or more factors. And again, remember that 0 and 1 are neither. Now, here's your question that I'm going to ask tomorrow, and I want you to think about as we're doing this. I want you to talk. We'll talk more about prime and composite doing activity to look into that as well, but I also want you to think, why is 1 neither prime nor composite? Why is it neither? You know, why can't it be composite, or why can't it be prime? I want to talk about that tomorrow, and I will see you then.